So today we're going to be learning about benchmark fractions in order to help us know which fraction would be the greatest fraction when we were comparing it with something else. And benchmarks are just spots that we're going to see on our number lines that can help us decide that. We'll see benchmarks when we see our number lines where we've seen 0 and a 1 there for the whole thing. And we're going to look at halves because halves are easy to look at and figure out, and that's why you will see them used a lot as a benchmark. So we're just going to go ahead and start looking at some examples so we can see just exactly what that means.
How can benchmark numbers be used to compare fractions? Think about this question during the lesson. Carrie wants to buy 2/6 of a container of roasted peanuts. Alan wants to buy 2/3 of a container of roasted peanuts. The containers are the same size. Who will buy more peanuts? What are you asked to determine? What is important to know before you compare fractions?
So it's wanting to know who, of course, had the most peanuts. And what the important thing is that we have to remember when we compare fractions is that you cannot compare them if our fractions do not have the same whole. So if we see right here, we see a picture of a container full of peanuts, and both of them were going to have a container that was full of peanuts. Again, they had to have the original whole things being the same, or it makes it hard for us to compare. There's not a way for us to compare without having real objects if our wholes are not the same.
You are asked to determine the person who will buy more peanuts. Before you compare fractions, it is important to know that the wholes are the same size. You can compare fractions to commonly used benchmark numbers such as 0, 1/2, and 1.
So here are the fractions that it asks us about to start with, the 2/6 and the 2/3. Now, we have been looking at these already. So we have been looking at these already and comparing fractions. We see 2/6 and 2/3. Now, what I noticed that we have the same here is that we have the same numerator. And we talked about if we have the same numerator, that means that we have the same number of pieces that we're thinking about. It's our denominator that lets us know how many of those equal pieces we have in all, and that helps determine the size. We talked about the more pieces that we have, the smaller those pieces are going to be, because that means we have cut things up more. So our pieces are going to have to be smaller. So looking at this, and I see 2/6 and 2/3, thinking about them and comparing them the way that we have been with those numerators being the same, is I see that my 6 is more equal parts. So that means those parts are going to be smaller. So saying that I have 2 of these 6 is less than having 2 of the thirds. And we could come and we could look at that right here. We're going to go and do a half, okay, to start with. And if I come over here and get all of this divided into my sixth. So there's 1, 2, 3, 4, 5, 6. But what if I was looking at it being in thirds? Well, if I was looking at thirds, I would have these right here. Okay, so that would be 1, 2, 3. So if I come across, if I had 2 of the red ones, 2/6, of course we can see that that's smaller than if I had 2 of the blue coming over here to the second blue. So that is one way that we have talked about looking at them. So let's go ahead and just put that, saying that 2/6 is less than 2/3. So we can look at it thinking about it. We can look at it on a number line, but we're also going to think about another way to look at something. When you think about half of something, okay, you're having those two equal parts. So it was like dividing by 2 when we were looking at multiplication and looking at division. We're just splitting it in two, splitting it in half. We say half all the time, and usually know what that means, putting stuff together. So let's stop for a second and look at this 6. So I want to look at that 6 and I want to think, what would half of that 6 be? So if I had half of 6, that would be 3. So if I had 3 6, that would be half of them. Well, since here it shows me that we only have 2 of them, then I know that it's going to be smaller than 1/2. And if I come over here and look at my 2/3, I see that I have 2 of my 3 parts. That means I almost have all of them. If there's only 3 of them and I have 2 of them, that means I'm getting down here close to having the whole thing. And if I'm close to having the whole thing, of course, I'm going to be closest to 1. If I do not even have half yet, then that has me down here being closer to 0. So that's one of these benchmarks that we could talk about, is looking at a half, okay, knowing that something is halfway in the middle, knowing that something is really close to being the whole thing. So if I see something over here that 2, like I said, being really close to the whole thing, I know it's closest to 1 because I almost have everything. Over here, I do not have half of them because half of them would be having 3 of them. And so because half of them is having 3, the 2 is less. I know it's less than 1/2. If it's less than 1/2, that means it's closer to 0 than it is one whole thing. And this just takes some practice to think about thinking about what half of something would be. And that gets us back to thinking about our equivalent fractions that we've talked about earlier, showing me that 1/2 is the same thing as 3/6, because having 3 of my 6 pieces would be having half. So looking at all these different things that we've talked about, fractions, different ways to compare them. We saw pictures, we've saw fraction strips, we've saw number lines, and now we can just think about it by looking at our benchmarks and of course using our numerators and denominators about what those things mean, what those numbers in those parts stand for, to help us to be able to figure out which fraction is going to be the greater fraction, or depending on how they ask it, which would be the least fraction.
Compare each fraction to the benchmark number 1/2. Then, see how they relate to each other in size. 2/6 is less than 1/2. 2/3 is greater than 1/2. Without looking at the containers, how can you tell that 2/6 is less than 2/3?
That is just going back to where we talked about how we have the same numerator and we look at our denominator to find the size of our parts, because here we have 6 of them, so having 6 parts is more than having those 3. When we have a greater number of parts, those parts are going to be smaller. And so having 2 of the smaller pieces would be less than having 2 of our larger pieces. So that's just reminding us about comparing using our same numerators.
You can tell that 2/6 is less than 2/3 because the numerators are the same and you can compare the denominators. The fraction with the greater denominator is less than the other fraction. What is the missing symbol?
Select your answer.
So we've already said a few different times that 2/6 would be two smaller pieces than having 2 of the thirds, which means that 2/6 is less than 2/3. So we need to find our less than symbol.
2/6 is less than 2/3.
Remember, 2/6 and 1/3 are equivalent fractions.
Alan will buy more peanuts than Carrie. Now you know how benchmark numbers can be used to compare fractions.
Now, she just said to remember that 2/6 was equivalent. That means it's equal to 1/3. So how do I know that? Why would I have thought about that? Well, if we look over here, if I can compare how these things work to determine if some fractions that they give me are equivalent or not, especially when I'm looking right here and I see, the numerators are not the same, the denominators are not the same. But what I do see is I want to see if there is a relationship between the two. So right here, there's a 2 and a 1, a 6 and a 3. If we notice, if I have 2 of these, that's my 2. And then if I have 2 of these, that would give me 6, because 1 plus another 1 is 2. 3 plus another 3 is 6. So since I could take this fraction right here and double both of the numbers, the number that it gives me in the numerator and the number that it gives me in the denominator, I can see that those are equivalent fractions, that those are the same, because their ratio, in other words, how they compare and go together with each other, will let me see that those are equivalent. Again, because if I double my numerator and I double my denominator, I would have to do the same thing to both of them. I couldn't say to double one and triple another. It would have to be the same. If I double each of those, I get the 2/6, and that is a way for me to know that something would be an equivalent fraction without having to look at a picture or see it on a number line.